You know, we count on our machines to be incredibly precise, day in and day out. But what happens when that precision starts to, well, drift? What if the secret to a perfect cut wasn't some high-tech computer, but a simple, overlooked piece of metal?
We've all been there, right? You run a part and it's just off. There's this looseness, this slop in the movement you just can't seem to pin down. You've checked the code, you've checked your tools, but the problem's still there. So what's the invisible gremlin messing up your work?
Well, believe it or not, the answer is usually this: a little tapered wedge that is, without a doubt, the unsung hero of mechanical stability. It's the one thing that separates a machine that's perfectly dialed in from one that's just all over the map.
So let's meet this hero. It's called the gib. The best way to think about it is like one of those little wooden wedges you jam under a wobbly table leg. Its entire purpose in life is to take up any and all extra space, to get rid of that play, and to make sure every moving part is held in perfect, solid alignment.
Now, the thing to remember is that the gib is a precision wedge. See, over time, the surfaces the machine slides on, they're called guideways, they start to wear down and tiny gaps open up. The gib is specifically designed to be pushed into that gap, tightening everything back up and basically restoring the machine's factory accuracy.
And this is where it gets really tricky. Adjusting a gib is a true balancing act. If you leave it too loose, the main moving part, the saddle, can literally lift up in the middle of a cut. That's where you get that sloppy feeling and bad parts. But if you go too tight, whoa, the slides will bind, you'll overload the motors, and the whole thing might just refuse to move at all. It's a razor's edge.
The good news is, for most of a machine's life, keeping this balance is just a matter of routine adjustment. This is your first line of defense against inaccuracy, and it's a pretty straightforward procedure every good operator should know how to do.
So let's take a look at the Z-axis. Notice the wording here, snug. This isn't about using a torque wrench, it's all about feel. You tighten one side to push the jib in, you get it snug, then you back it off just a little bit. Then you tighten the other side to lock it right there. And that last step, verification, is absolutely crucial. You check the motor load to make sure nothing's binding, confirming you've hit that perfect, microscopic tolerance. And get this. This is the level of precision we are talking about. The target for that lost motion, that slop, is somewhere between +10 and -20 microns. To put that in perspective, a single human hair is about 70 microns thick. You are literally adjusting this massive piece of machinery to a tolerance that's a tiny fraction of a single hair. Amazing. All right, moving on to the x-axis, things get a little more interesting because the way you adjust it actually changed over time. So we're going to look at both the old way and the new way.
On the older machines, you've actually got 3 separate gibs to deal with, and you have to do them in the right order. And again, it all comes down to feel. You tighten it till it's snug, then you carefully back it off, literally feeling for the exact moment the backlash disappears, and then give it just a tiny bit more. It's a process that takes a ton of patience and a really sensitive touch.
Now, the newer style is way more direct. It uses this really clever concentric screw setup. You just loosen the inner lock screw, use the outer one to push the gib all the way in until it stops, and then back it out a very precise half turn before locking it all down. It's much more repeatable, less about feel, and really designed for consistency. But what happens when you run out of room to adjust? After years and years of wear and tightening, you just can't push that jib in any further. This is where we leave the world of routine maintenance and enter the realm of true mastery. That's right. Once that jib has been pushed in about 7 to 10 millimeters over its lifespan, it's done. There's no more taper left to do the job. The only way forward is to replace it completely. And this is not a simple part swap. The new jib has to be meticulously hand-fitted to that specific machine. And that hand-fitting process, it's a genuine industrial art form. It's called scrapping. And we're not talking about throwing things away. We're talking about removing material, micron by tiny micron, to create a surface that is absolutely perfect. This quote from an old training manual says it all. You're not just making it fit. You are scraping to create a surface that is geometrically accurate, has the perfect number of contact points for support, and even holds oil for lubrication. It's a craft with multiple critical goals. So, what in the world are bearing points? Well, they're the tiny microscopic peaks on the metal that actually touch the other surface. You see, a perfectly flat, smooth surface would actually stick and seize up. Instead, the goal is to create this beautiful pattern of 8 to 10 tiny contact points per square inch. That allows oil to sit in the little valleys between them, which is the key to smooth, stable movement.
So how do they actually do this? Well, it's this painstaking process. You put a thin layer of special indicator paste on the jib, you rub it against a dead flat granite surface plate, and the paste transfers, showing you exactly where the high spots are. Then, with a special hand tool, you scrape those high spots off, and you do it again and again and again. It's the slow, methodical dance of marking and removing until that perfect pattern appears.
So once the surface is prepped, you have to fit the taper itself. And this is pure craftsmanship. You slide the new jib in with just your thumb. You gently rock it to feel where it might be a little loose, and then you scrape material off the opposite side to fix it. You are literally shaping the wedge by hand until it fits into its slot with zero play, anywhere along its length.
And finally, once that perfect fit is achieved, you do the last mechanical steps. You mark the correct length, you lay the old jib next to the new one to transfer the exact location for the screw slots. Then you cut it, machine it, clean it up, and install it. All that incredible hand fitting comes down to this one clean, final installation.
And here's the beautiful sign of a job done right. A brand new, perfectly fitted jib won't sit flush with the edge. It'll actually be recessed by a couple of millimeters. And that's on purpose. That gives it those 7 to 10 millimeters of room for all the future adjustments it will need over the next decade of its life.
So in the end, this one little part, the gib, it really captures the entire spectrum of machine maintenance, doesn't it? It starts as a simple adjustment that anyone can learn, but it ends as a master's craft, an essential skill that keeps these amazing machines cutting true.
And that kind of makes you wonder, doesn't it? In our world of automation and push-button everything, what other hidden, seemingly simple parts are out there, quietly depending on an incredible level of human skill and hands-on mastery to keep our world running with precision?